Okay, so let's summarize our two vocabulary terms. Nuclear charge, you're always going to think about a pull. Think about two lovers are hugging. When you think about electron distance, you're going to think about the rings and think about the protons and electrons, and if they're close together or far away. Okay, those are the pictures you're going to have in mind. Okay, so the first trend or the first pattern that we are going to talk about is called atomic radius. Atomic radius is the size of an atom, a neutral element. The distance is from the nucleus to the valence electrons. Now, when you say the word radius is singular. Now, if you're talking about two different radiuses, like the word radiuses is not a real word, so we say radii. So this is just here so that you don't freak out about this word. Radii is just a plural version of the word radius. Okay. If you notice the picture here, you notice that it gets bigger going to the left. Gets bigger going to the left, and it gets bigger going down. So we're going to write this pattern right here. The atomic radius gets bigger as you go from right to left across a row. Once again, in chemistry, we say that's a period. The atomic radius gets bigger as we go from top to bottom down a column. In chemistry, we say group. Okay, so make sure you always use your vocabulary words period and group. So you have to memorize that it does get bigger to the left and down. Now that we know this piece of information, we can answer some questions about the patterns that we see. Now there are some notes that I am going to skip here. You can ask your teacher for them, but I am going to go ahead and skip to the practice problem here. Okay, so let's look at this practice problem on the next page. How do we answer these types of questions? Well, let's first start with the question. It's right here. Okay, which of the following elements has the smallest atomic radius? So it's looking for the smallest atomic radius between arsenic, phosphorus, antimony, and nitrogen. There are 3 steps you should do before answering the question. So we are going to find these elements on the periodic table. So I would use a larger periodic table and then find them on this tiny one. But basically, these elements are going to be either in the same row or the same column. So we notice here that nitrogen, phosphorus, and antimony is sitting right here, okay, on your periodic table. So I am going to highlight it over here as well, just so you know where it is, okay, just like the general idea. We can see that all of these elements are in the same column, so I'm going to make a little side note right here. Now, according to our notes, we know it gets bigger going down a group. So I'm going to put an arrow going down this way. So that's like a note to self. Now let's answer the question. It wants the smallest atomic radius. So it's the smallest up at top, and it gets bigger going down. So the smallest one is the one that is up here, which is the element. So the smallest one up here is going to be nitrogen. So I'm going to answer the question. Nitrogen has the, and this goes right here, and you're going to rewrite it, okay, in this little section right here. So you're going to write smallest atomic radius. Remember, atomic radius is the size. It's the smallest size between all of the other 4. In this, and because this is a column in chemistry, you have to use the word group. Okay. Now, once you determine that these 4 elements are in a group, okay, then what happens is that the other answers are also have to match the fact that you use the word group. Okay, so these 3 boxes here that I did in blue have to match the idea of a group. So what do I mean by that? Remember that we talked about in our notes here that when we have a group, these are the 2 most important words in our periodic table trend. So you're going to put the word energy level here, and you're going to put electron distance here. Once again, this is from your previous notes here. Those are the two most important words when we're talking about a group, okay? So these three must match together: group, energy level, and electron distance. Once you have this, you can now answer the question depending on how you answered it. So nitrogen has the blank number of energy levels, which means it has the blank electron distance. Okay, so in comparison to the other four elements here, you're saying nitrogen has how many energy levels? Does it have the smallest or the largest number? Okay, so you know your energy levels are here, 3, 4, 5, 6. So you notice that nitrogen only has 2 energy levels, but the other ones have 3, 4, and 5. So here you would say it has the smallest or the lowest number of energy levels. Okay. When it has the smallest number of energy levels, then what does that say about our distance? Remember, we drew this picture over here. If you don't have that many energy levels, you are pretty close together. When you have a lot of energy levels, you are very far apart. And nitrogen only has 2, so they are very, very close together. So if we go back to our question here, then we say it has the smallest electron distance because they are close together. Okay, a little hint for you is that these two words should always match, here and here. Okay, now this last little blank here doesn't always match the other word, so you have to be extremely careful. Okay, so now let's review what we wrote to see what should go in the last blank. We determined that nitrogen is the smallest size of the elements in this column called group. Because it has the smallest number of energy levels and because it doesn't have that many rings, right? It only has 2. The distance is really, really small. So when the distance is really small, then what kind of attraction should it have? Do they love each other very much? Okay. Or do they not? Is the attraction weak or is it strong? And it's very, very strong because they're so close together. So you can write the word strong here, or you can write largest. The word that they suggest is largest. Okay. You might be a little bit confused, but let's try one more example so you can see how this works. Okay. So the next example is on the next page. The question says, which of the following elements has the largest atomic radius between germanium, cobalt, zinc, or calcium? So you need to find these elements, and it's all dependent on whether they are in the same column or the same row. So if you go back to your periodic table, you can probably find it. Here's calcium, here's cobalt, here is zinc, and here is germanium. Okay, so you can spot those 4. So let me just do a quick coloring here so you can see it. You're just trying to get a generic idea here. You can see that they are all in the same row. According to the trend, it gets bigger going to the left. So you draw your arrow as a reminder to yourself. It wants the largest sized element, right? The largest size. So if it gets bigger going to the left, then good old calcium must be the biggest one. So the answer to this question is calcium. So you're going to write calcium has the, and you're going to take this question and put it right there, has the largest atomic radius, the largest size of the given elements in this. Instead of row, you're going to use a chemistry word, period. Now, when you use the word period, there are some key words that come into play. So here's the word period. So this blank and this blank all depends on that word period. Now remember, when we use the word period here, these two are the most important words that we are going to use, which is protons and nuclear charge. So I'm going to write protons here, and then I'm going to write nuclear charge here. Okay, so now we know what words go in the blank. We can appropriately write the correct sentence. Okay, so if calcium has the largest size, why does it have the largest size? Does it have the smallest number of protons or the largest number of protons? So if you look at our periodic table, we notice that calcium only has 20 protons. The rest have 27, 30, and 32. So to answer this question, we say that it has the smallest or the lowest number of protons, okay? If it doesn't have that many protons, that means the love is very, very small. It doesn't have that much love. If that is the case, then it will have the smallest nuclear charge. Remember, nuclear charge is all about the pull. It's not going to give it a very strong hug. It's just going to give it a very weird, cringy hug. Okay, so this word and this word will always be the same. They should match. If you don't have that much love, you're not going to pull them in for a nice hug. Okay, if that's the case, okay, then you're going to have to determine this last word here, but you have to be extremely careful because it doesn't always match. So now let's try to figure out what word goes here. If you have not that much love, so low protons, you're not going to pull them in for a really nice hug. They have very low nuclear charge. The pull is very small. If that's the case, does it mean that you love them a lot? Is the attraction strong or is it weak? It is very, very weak. Okay, you don't love them very much, so it has the smallest number of attraction. It is very cringy type hug. All right, so those are your two examples. Okay, so look through your notes and you're going to try to do the next couple problems on your own, just like we did in this example. All right, good luck.